Hey, Nine. Today in class, you're going to go through scientific notation. Now, scientific notation is just a way of representing really large or really small numbers in a simple way. Remember those times when we got our calculator out and you tried to multiply really, the biggest numbers you can get, and then your calculator would give you a funny display? Or even your mobile phone, when you multiplied something, it'd give you like an E with a number after it. They're just ways of expressing numbers in scientific notation. So before we start, let's just think about our number system. And let's think about just the number 3. And if I multiplied 3 by 100, what I'm actually doing, we would say 3 times 100 is just 300 because we put 2 zeros on it. But what we've done to that 3 is we've picked that 3 up and we've moved it 2 places in our number system. We've slid it along and we've put zeros as placeholders, because I can think of that as 3 times 10 squared. You can see I've moved it 2 places along and I've put 2 zeros in it. If we were to do something like this, and I'd have here 0.03 times 10 to the power of 4, which is 0.03 times 10,000, you can see I've got 4 zeros there. So what I'm actually doing is I'm picking up this number 3 and I'm sliding it 1, 2, 3, 4 places. And what we're doing then is we're putting zeros to fill in the place values that are left over. Effectively, scientific notation is just physically writing down this movement pattern. So let's look at some examples. Along the way here, as I've completed an example, can you pause and write that down? So let's look at this first number, the number 20,000. Well, the number 20,000, the decimal point is at the very end of it. So to write 20,000 in scientific notation, I need to identify the first number that is not 0. So the first number that is not 0 is the 2. So I write the 2, and the very next thing is I put the decimal point there. So this decimal point, it's going to jump all the way there to after the 2. I'm going to write 2.0 because there's no numbers, no other values after the 2. I'm going to then say times that by 10. And I need to then count how many spots did I move it. Let's do different color. 1, 2, 3, 4. So I say this is 2.0 times 10 to the power of 4, because I have slid that 2 4 places along to get it to 20,000. So that's our pattern for scientific notation. It's find the number that is not the first number that is not 0, and the decimal point needs to be directly behind it. And then we count how many times did I move that decimal. For the second one here, 88,760. Well, identify the first number that is not 0. Decimal point would have been at the end of this number. We want it to move behind the first non-zero number, so I'm going to write 8.876 times 10. Now its power is going to be 1, 2, 3, 4 again. So that one is going to be 10 to the power of 4. So 8.876 times 10 to the power of 4. This example here, number 3, we're going to have 317,000 is going to equal, identify the first non-zero digit. Remember the decimal is going to move there. And now we need to count. 1, 2, 3, 4, 5. So we're going to write this one as 3.17 times 10 to the power of 5. Now I'm going to worry about this idea of rounding it to one decimal place. So I look at the number 1 and go, what's next door to number 1? Next door to number 1 is the number 7, and we know the number 7 is going to make the 1 round up. So we're going to write 3.2 times 10 to the power of 5. And that's our trick for scientific notation. So just remembering, it is identify the first number that is not 0, identify the location of the decimal, move it behind the first number that is not 0, and count how many times you had to jump that decimal or slide our number system along. What we're going to look at here now is let's think about writing numbers in ascending order. And the first thing we're going to do when we write our numbers in ascending order, ascending means small to large. So let's have a look at all our numbers. And the first thing, because I've noticed everything's written in scientific notation, I'm going to look for the smallest power. So I can see 10 to the power of 2 is the smallest power. So it is going to be my smallest number. So 1.08 times 10 to the power of 2. What's my next smallest? 10 to the power of 3. So then it's going to be 1.08 times 10 to the power of 3. Now I look for the next, but now I've got an issue. Both these numbers are to the power of 5. So now that they're the same, what I look at now is which one of these two numbers down the bottom here is the biggest. And 5.35 is the biggest. So I'm then going to keep going in my order. I'm going to write 5.3 times 10 to the power of 5. And then the biggest number was 5.35 times 10 to the power of 5. Finally, evaluate the following, leaving your answer in scientific notation. To do this, first, multiply the decimal numbers. So I'm going to do 1.3 times 2. 1.3 times 2 is 2.6. Second, add the powers. 7 plus 4 is 11. So this one is going to times 10 to the power of 11. Third, check only one number is in front of the decimal. So I have a look here and I can see the number 2 is the only number in front of the decimal. So I'm happy, I can move on. If it was not, and for example, just off to the side here, after I multiplied, let's say I did 1.3 times 2, no, let's not worry about that. Let's say after I did my multiplication, I ended up with a number that was 14.8 times 10 to the power of 5. Let's say I've done my multiplication and this is my answer. When I come back and check, you can see I've got two numbers in front of the decimal, and that's not what I want. So what I need to do is I need to get this decimal point and I need to move it here. So I would end up writing 1.48. But because I had to move it one more spot, I need to add 1 to that power. So then that would become 6, 10 to the power of 6. Because we always only want one number in front of the decimal. All right, year 8, pause the video here, go through and complete the questions that are in the announcement on Learning Activity 1. Once you've done that and you've had your brain break, come back and watch the second part of this video. All right, year 8, now that you've completed those learning activities and your brain break, I want you to have a look at writing the following in scientific notation. So instead of starting with really large numbers, we're going to start with really small numbers. And we're going to do very much the same process. We're going to identify the first non-zero number. The first non-zero number is the number 8. So what that means is I want, my decimal to now become after the number 8. So I'm going to have 8.0. And now I need to go, well, I'm going to multiply that by 10. And now I need to know how many spots did I move it. I moved it 1. I moved it 2. But this time I moved it in the opposite direction from before. So because it's the opposite direction, because now we're dealing with small numbers, I write 10 to the power of -2. So let's look at example 2 here, remembering to pause the video to write these down. 0.00098786 is going to identify the first non-zero number. The first non-zero number is the number 9. I want the decimal point to be after that 9. So I'm going to end up having 9.786. Then count how many times did I move it. 1, 2, 3, 4. So this one is times 10 to the power of -4, because we went the opposite direction from earlier. All right. Earlier, when we jumped our decimal to the left. Here we can see we're moving our decimal to the right, which was opposite from earlier. So because it's opposite, we're going to put our negative. But when I look at this question, I haven't finished answering it. It says now round it to 2 decimal places. So my second decimal is the 8. I stop there. I look next door. The number 6, it makes our 8 round up. So we end up with 9.79 times 10 to the power of -4. All right, that's what you need to finish learning activity 2. And then quickly, learning activity 3. Write the following as a basic numeral. So 3.8 times 10 to the power of 4 is going to equal to 3.8. See our power? That's how many zeros I'm going to write. 1, 2, 3, 4 zeros. Now I'm going to move my decimal 4 places as well. 1, 2, 3, 4. This is where I want my decimal point to be. So our answer is going to become 3.813.0. Hopefully that was okay. Remembering to pause it again. Looking at this one, I need 5 zeros, but because it's -5, the zeros need to go in front of my number. So I'm going to have the number 7.62 times 10 to the -5 equals, now I'm going to put my 5 zeros, 1, 2, 3, 4, 5. Now I'm going to write 7, 6, 2. And I have to move the decimal, which is here, 5 places back. 1, 2, 3, 4, 5. This is where I want the decimal to be. So now I write it. So just cleaning that up, 0.00000762. All right. So the trick to here is whatever the power was, that's how many zeros you write. If it was a positive power, the zeros go at the end. If it was a negative power, the zeros go at the start. And then count your decimals. Finish off your learning activities that were posted in the announcements, and have a go at the extension questions if you feel confident.